Hey guys, Mr. Milton here. Today we're going to start our functions unit. We'll talk about interpreting graphs. At the end of this video, you should be able to interpret graphs by describing what is happening at each section of a graph, and you should be able to analyze situations in sketch graphs to represent a given situation. Alright, so let's start with the graph. Each graph has two axes. An x-axis goes left to right, and then a y-axis which goes up and down. Okay, we can also say that the x-axis is the independent variable, and the y-axis is the dependent variable, just to throw that in here right now. Okay, each of these has a label. Okay, and it's important for us to recognize that label because that'll tell us what we can actually see in the graph. Okay, typically the x-axis is labeled time. Like I said, it's the independent variable, and time is something, when we say independent, it means it can't really be affected by anything else. Time just goes. So a lot of times that is our independent variable. The y-axis can have a variety of labels. Also, the x-axis can have a variety of labels, but it's typically time. Alright, so let's look at this graph. What is this graph showing? A couple things we should look at to find out: the title, trip to London, and then the labels of the axes, so altitude, time. So what is it showing? It's showing the altitude of a plane over time. Okay. Alright, so where's the plane at its highest point? And so we can see at its highest point, altitude up here, it's cruising altitude. At its cruising altitude, the plane is at its highest point. Number 3 asks us, where is the plane going the fastest? Now you always have to check yourself with these questions on interpreting a graph, because a graph is just a snapshot. Okay? Notice that this graph doesn't tell us anything about speed. It's telling us altitude, it's telling us time, but about as fast as it's going, it doesn't give us any clue. So we can't answer that with this information. Okay, we don't know. They don't tell us. This graph is measuring altitude. Okay, and that's okay. That's why you see a bunch of different graphs about the same situation, because it measures different things. Okay, number 4 says, what does the flat portion of the graph represent? The flat portion of the graph here happens here. It represents a constant altitude. It means that we are not getting any higher or any lower. Notice it doesn't mean that the plane's stopping, because that would be really bad for it to stop, you know, somewhere up here. It just means that it's not getting any higher or any lower. Okay. Alright, let's look at this next graph and situation with it. So use the graph below to answer the following questions. What is this graph showing? Okay, commute home, measuring total distance and time. It is measuring the distance traveled for a person's walk home. Okay, where is this person going the fastest? And how do we know? Okay, notice that this graph talks about distance and not speed, but we can find speed from it. Okay, because what we can see is, hey, where the distance is changing the fastest, that's where the person must be moving the fastest. And so while he's walking here, you can see a really slow change in distance. Okay, while he's waiting for the bus, there's no change in distance. And then here, he's taking the bus. Look how much faster his distance changes than when he was walking. So actually, we can tell the person, when the person is taking the bus, he's going the fastest, because that's where the line rises the fastest. Or I could say steepest. Okay. What does the flat portion of the graph represent? Okay, we can say that's a constant distance. So his distance traveled has stayed constant, or we can just say, kind of more normal terms, him staying still, staying in one place, not moving. Okay, and that you see the flat part happen when he's waiting for the bus, probably at the bus stop. Okay, and then why does this graph never go down? Notice that the total distance the person walks can never decrease. Okay, because we're just measuring how much he walks, can't ever decrease. All right, flipping to the back where we get a few more problems here. It says, use the graph below to answer the following questions. And it asks us, looking at this graph, temperature, time, weekend, temperature, weekend. So that means a couple days at least. So a couple days looks like. Okay, what is this graph showing? It's showing the temperature over the weekend. Okay. Which day was the warmest? Well, if we look at these 2 days, and like we said, it's a weekend, so it seems like a couple days, then we can cut this in half, seeing that it warms up during the day and cools down at night, warms up during the day, cools down at night. It looks like 2 days. So which day was the warmest? First day. So whether that's Saturday or Friday, I don't know how people mark their weekends, but the first day was the fastest. Number 3 says, which season is being shown here? Notice that in our graph, we have labels for our axis, but we don't really have scales. Okay, so it doesn't tell us like, hey, this is 90 degrees and this is 70, or this is 32 degrees and this is 16. It doesn't really give us a scale that we can even make a guess here on what season is being shown. So really, there's not enough information to answer this question. Okay, it's not measuring that. And so that's kind of similar to the first graph that they asked us how fast it's going. Every graph does not answer every question. Okay, so you make sure you analyze the graph, see if you can find your answer from it, but in this case, we cannot. All right. Here we go. It says, answer the question from the given graph. So we have inline skating after school. We have a graph showing speed and time. And so it's asking us to find which scenario best fits the graph. Let's notice what's happening here. As we start, our speed is going up. So our speed is increasing. Then we get to a constant speed, and we increase the speed again until we slow down for some reason. Like we slow down pretty quickly. And we increase speed again, a little bit slower than the first time, remain steady, and then we come to a gradual stop. Okay, so let's see what's happening. Scenario A says Billy skates up a hill and maintains his speed for a while, then goes up a very small hill only to quickly descend down a very steep hill. Okay, I'm going to stop this here. Okay, so we do have hills in our graph, but notice what our graph is measuring. Our graph is not measuring altitude. Okay, if our graph is measuring altitude, then this situation lines up pretty well. But our graph is measuring speed. If you go up a hill, that means your speed would probably be pretty low going up a hill on inline skates. Okay, so A does not fit the bill. Excuse me. All right, B. Billy slows as he goes up a hill. Again, he's slowing. Maintains a constant speed for a while, slows a little bit more, again, not slowing, and then races down the hill very quickly. Notice that when we race down, this is actually showing that we're going slow because it's measuring speed. So everything that this said so far can't work. So by elimination, we should know it's C, but let's read it so we can see how it makes more sense. C, Billy skates down a hill, which makes sense because if you're skating down a hill, your speed increases. Maintains his speed for a while, then picks up speed before coming to a sudden stop, and that makes sense. He increases his speed again, is constant for a while, and then slowly comes to a stop. See, all that fits. That's good. Alright. Next it says, sketch 2 graphs of the top thrill dragster at Cedar Point. The first should show the speed of the dragster over time, while the second should show the height of the dragster over time. So we just talked about how you can get those confused here, but we want to make sure that you keep them separate in your mind. If you never ridden the dragster, okay, you can search up video on YouTube to find out how that goes. And then what I want you to do down here, make your 2 graphs, very simple graphs here, with time as your x, and then one as your speed, measuring the speed of the ride, and the other measuring the height or the altitude. Okay, so do that altitude. Bring that in with your completed notes. All right, see ya.